test. Is this on? Okay, perfect. Hello everyone, welcome to one more evening of the compiler project. On Tuesday, what we've done was we went over the bug we found in Alex last week, and we've started working on the linker phase, which we've done already because there wasn't a lot to do. And we've started working on the assembly, as in the image generation process, to take a bit of a break from all the AST stuff. I think this evening I'm just going to continue on the image generation thing because that's just fun to do. So, let me just adjust this. The thing we were working on Tuesday, where we left off, was having a way to declare templates. I'm not sure about this. I might have to revisit this because the problem is it's all relative to the start color, which means it's not always going to be very clear what's happening. But maybe we'll see. We'll see if it's useful. So today, what I'm thinking of doing is start doing the image generation process, start doing some of the templates, and start building programs. Let me just go back there. Perfect. And now let's get started. There are two libraries that we're going to need. I was looking up before getting started. The graphics image library. Oh, you can't see this with my face. This one that has a bunch of image manipulation functions, which I think is exactly what we need because we just need to be able to compose images together. So let me just add this dependency quickly. And the other one is file embed, which is the one I want to use to be able to read the template files at compilation time. We don't need to bundle the files with the program. They just need to be like read at compilation time for the templates. So this is gonna be good enough. So file embed. Now for our assembly. What we're going to want to do is basically given a list of functions that we have obtained during the linking phase yesterday, which is just this, a list of like for each function, the number of entries and a list of instruction. We are going to want to convert that into an image for each function. That will give us the size of the image. We can create the base template of the resulting image and just like paste the images of our functions into it. So let's do that. I guess the size, the maximum size of the image is going to be some constant times the number of functions for the width. And for the height, it's going to depend on the size of the biggest image, of the biggest function, I suppose. So we need to collect that, I suppose. How do we do that? The width we already know from the start. The height, do I want to do a fold or do I want to... What's the good solution here? Because basically I'm going to want to map something over the list of functions to generate each function separately. The question is, how do I return the height? I guess each thing will give me an image and its height, or just the image, I guess. Yeah, I suppose the image has probably a way. Can I get the height of an image? Dimensions? No. Ah, dimensions. There we go. rows and columns. So I guess I can just return an image per each for each function, and that will tell me everything I need to know um, about the size of the image. Yeah, let's do that. So for each function, I can start by generating a list of or do I? No, I will need to know the size of each image before I can do. I guess I could do the lazy thing again where I go through the list of functions while applying them to an image, but that image is lazily created after the fact when I have finished my loop because I have computed the size of the biggest function. Or I can just do two traversals. I think that's fine. So that's just going to be mapping something over the functions, which I can rewrite as a do block in the list monad. So for each entrances and instructions in my list of functions, generate image for the list of instructions, and return. So that gives me the image. And that gives me could I because I'm gonna get a list of tuples if I unzip that result. No, actually, I don't want to do that because I need this int associated with each function. So no, I don't want to do that. However, so it's going to be the number of entrances I'm going to keep unchanged. I'm going to return the image associated with each function. And max height is going to be the maximum of map, whatever this function is called, column, no, rows, of the second element of our images. So here we are going to need, is it graphics.images? It is. Okay. And now the only thing left to do is to start generating an image. And I guess after that, we have the max height, the max width we can compute based on some constants. If we look at this example here, there's probably ways to do better. I probably don't need the black border because the border of the image functions the same. There's probably ways to make this simpler. I guess, yeah, I guess I can remove the black border, keep the rest of the image, and have on the left column here something that forces the pointer to rotate so that we use the second row as the one for function selection. And that means the width of the image is going to be for each function 1, 2, 3, 4 in the middle, 5, 6, 7, 8, 9, 10. So 10 pixels per function. 10 pixels per function plus like one extra on each side, probably. Something like that. And then that's going to be the result is going to be an image, which is going to be the result of folding the the blank canvas. It's not going to be blank. It's going to be the initial image with add function. And the list we're gonna zip over is gonna, excuse me, is gonna be a zip of each function and its index. Okay. Now, how do we generate an image for a list of instructions? This is where we're gonna need to start making some templates, I suppose. I guess we have the problem here that I don't know. Can I resize an image easily? Border. Mm-mm-mm. I probably want to create the image at the right size from the start. Actually, could I? Huh. Oh, that's what I was looking for. Okay, so resize will try to adjust. What I want is there a way to truncate basically? Rotate, rotate, flip. Is there a way? Because I could make. Hmm. Yeah, I guess candle size is probably what I want. And the resolution strategy. Yeah, okay, I can just say fill white or something. Perfect. Okay. So that's what we want. We want to start with an image that has just the basic, which is the entrance, I suppose. And then we want to do a canvas resize every time we have to add an instruction. That's probably the easiest. Okay. So first, we're going to need the entrance block of a function, which is also how the function is going to start. Although I guess there is a difference between an entrance block in the middle of a function and an entrance block within a function. Like at the start, I mean. Although I guess that line is technically not required. And I guess actually every function will start with an entrance already. So the start canvas will not. I guess the start canvas will just be the template for the start of a function, is just going to be that basically. Okay, so. What do we want to do there? We probably want to have the base image, which is going to be how do we create an image with this library? There's probably like a make image or something. Make image. There we go. Dimension returns a pixel. Let's see. And okay. There was a thing of pixels here, pixel RGB, okay. So I guess it's gonna be fairly easy. Our image is gonna start as a row of black pixels. So it's gonna be make image of Underlying image representation, we probably want, I was looking at this, vector unboxed is probably the easiest. The dimensions are 1, 6, I think. Yep. And the function that to a coordinate associates a pixel is gonna be a const. Actually, we probably want RGBA if that's supported, because we are gonna want to have, it is, we are going to want to have transparency. Actually, maybe, yeah, I think the size of this function must be larger than this. It is not just those 6 pixels, it is actually, it starts here, so it starts 2 above, and it extends 3 to the right and then 1 to the left. 3 to the left, 1 to the right. So it is actually 10. And it is 1, 2, 3. It is 3 high for now. However, we might want to use a template for this then. So probably get rid of this. It's probably going to be wrong. So our template, if we use a template we have described yesterday, let's do, this would be part of the stages. How do we want to call the template? What's the extension for them? TMP, I think, is fine. So this is going to be a, as mentioned, 10 by 3 pixel image. And it's going to be, if we go back to this, a lot of transparency actually. Although for now, I guess it's easier to make everything white, and we'll make things transparent when they need to be. So for now, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because the first 2 lines are just white pixels. I'm not going to include this entrance here because that's going to be part of the entrance. So 2 times, okay, followed by 1, 1, 2, 3, 6 black pixels. And 1 white pixel there. That's going to be the start of our image. And we are going to want to have, probably in there, something that makes an image out of this. Arguably, do we want to keep this intermediary representation, or do we want to just get rid of it and immediately make an image? Hello! I'm doing the assembly this evening. We've done the linking on Tuesday. So basically, given a list of functions that have like names pointing to other functions, how do we assign the unique address to each of them? And now that's done, we're doing some of the image generation. I've skipped a lot of the intermediary work, the actual compilation phase, name resolution, type checking, IR generation, because those are going to be the very complicated part, and I wanted to do something a bit easier this week. So I'm doing the image generation this week. I'm probably not going to finish today, but I'm hoping to make some progress. So yeah, I'm not sure. Do we want to keep this intermediary representation, or are we fine getting rid of it and directly generating an image? I guess this might be useful for debugging purposes. I might want to keep it. I That's a good question. I don't that much. The way I'm planning to organize, so oh yeah, I need to get into the habit. I've created a second YouTube channel to upload all of the history of the streams of this project. I need to remember that on YouTube the chat history will not be there, so I need to remember to read the question out loud so it's audible in the playback. So the question was like, how much do I need to care that a given pixel, like the color of a value of a pixel, depends on the previous pixel? And the answer is not that much, in the sense of like the way I'm generating my images. There should not be a situation where a given pixel will be entered by from two different locations. So I don't think that's much of a concern. It's only a concern for the template generation, where it makes writing the templates not very elegant, but for the image generation it should not be a problem. Basically, this strip here is just stating, is the current address within this function? If yes, rotate right. If no, continue, basically. And then we continue decreasing the value by one until we find the actual entrance. And then each function is just a series of instructions one by one. There's one thing we haven't done yet that's going to be complicated, however, which is integer constants. Which is basically, if the site, when I want to push a value on the stack, like I want to push 10, it is the push color transition, and the argument 10 comes from the size of the block for which I am pushing. Values on the stack are in 64s. I don't want to have to generate images with 3 billion pixels just for a push. So I'm going to have to figure out a way to decompose any image into a series of multiply, push, like adds, and so on. The easiest is probably going to be using a base 4, since I have up to 4 pixels in my image in my functions by default with this template. And maybe I'll change it to a base 8 or something. But I think that's the easiest. So actually, no, I want to keep this because this allows me to decide. I need to keep this actually because the idea of the template is that I'm able to generate it with different colors based on the starting color that I need, which means which means I can always select which color I need based on the previous color. So I need to keep this as the type. So I'm just going to introduce template equals just that, which is not very elegant as a type. Maybe we want to... Yeah, maybe we want to do something a tiny bit better. Let's do things properly. There is a difference, yeah, because I will want to have templates with that like have transparency in them, so I can superimpose them on previous images without modifying everything. For instance, I'll have a template for an entrance, which is this thing here. Like arrive here, enter here. This is a blue pixel, not a black pixel, and do this loop here to just go across it here and start the function. And I will want my entrance template to also contain this thing here because it needs to be added on the side without overriding what's above. So the template will be a rectangle that contains transparent pixels. Well, those need to be white because they need to be crossed, and therefore they will have those will be transparent. Those will be white, basically. So there is a difference there. No, it is. I mean, yes. It's less than transparent is I don't care. It's more than transparent is whatever was there before, because I'm gonna be composing the images by superimposing templates, and it's like I want to keep what was before. So I don't care as far as this template is concerned. I care as far as the image is concerned. I want to keep what was there before. So yeah, I think I'm just gonna make this a tiny bit more elegant. Template data, and I might just make that a vector of. I can't make it an unboxed vector because this is not unboxable, I think. But I can still make it a vector. Which means I'm going to need data vector, which I'm going to need to add to my dependencies. Yes, that's a pretty big import, I suppose. Okay, so how do we do that? We're going to change our read template here. I guess that's still more or less correct. The difference is, so rows is going to be the lines of the input. Columns is going to be the maximum, it's going to be the length. Sorry, rows is going to be the lines. Width is going to be the length of the rows. No, that's a height, sorry. The width is going to be the maximum value of the length of each row. The result of this is going to be a template in which we have the width, the height, and then we will have a vector. What's the construction for vector? Except I don't want unbox because those cannot be unboxed. I want regular vector. Construction. There we go. I suppose I want from list. I was trying to think of like, is there a better way to do this? But I think from list is exactly what I want. Because is there like I was thinking, is there a way to avoid doing? But no, I want it from list and hoping for some list fusion. But that means I probably need to flatten. Yeah, that's fine. So what we're gonna be reading is for each character C in the concatenation of the rows, so we no longer have the new line characters. What we're gonna do is just a translate. I don't need a translate function anymore. I can just inline it. So this is now pure of I could even not even I could actually no, I'm gonna not bother. I'm gonna keep translate, and I'm not gonna bother with a lists comprehension here. This is just a map translate. On concat of the rows. Okay. That means this debug function is no longer going to work, and I think I'm fine with it not working. It was a test last week, and I think we can do better than this. So I'm just gonna get rid of it. The whole point, however, of the template is that make image will take a color as a start color and a template and return an image. Now, since this is already a vector, is there a way to change? Ha, that's annoying. Okay, one of the ways to make an image is to use a function that takes a list of lists exactly like we had. So maybe it would have been better. I don't know. What's the difference in make image R and make image? Ah, okay. The type of the underlying representation is not given as an argument, and therefore must be inferred from context, I suppose. Yeah, I guess I can just use that. And as the function, just index within the image. That's fine. So make image from a starting color and a template is gonna be this make image function using a vector unboxed as the underlying representation. The dimensions are gonna be the template width and the template height. And the function that we're gonna give it, that is going to be for a given row and a given column, it's going to return the value which is in the template data at width times row plus column, unless it's x, y, and not row column. Let's check. Row column. Okay. Okay, so that should work. Except no, that will not, because this will give me a template pixel thing, and we need to convert that into a color. Okay. So it's gonna be a case of that, of, and we need to handle all four cases. The easiest is transparent, which is an RGBA. What are the values of RGBA? Is it pixel RGBA? Does it expect 0 to 256, or does it expect 0 to 1? Doesn't seem to say. Is there an example somewhere? This seems to be 0 to 1. Ah, yeah, there we go. And pixels of double precision. Yeah, I'm just gonna assume it's 0 to 1 for now. Oh, that's gonna be annoying. That means I'm gonna need to convert the RGB values I have from Pete to... That's fine. So this is gonna be 1110. Absolute color, I'm gonna need to convert that color. Relative, hue, light. It's always going to be relative to the starting color, so it's going to be a step, I think we called. Step, yes. So it's going to be step starting color, hue, light, or is it color last? No, it's this order. And convert the result. If it's the start, it is very simple. It's convert the starting color. Okay. And convert is going to be a big case here. Where we associate to each constructor I was right. Okay. And for all of those, this is going to be a pixel RGBA with some values and 1 for the alpha. Let's get the easy ones out of the way. Black is going to be 0, 0, 0. White is going to be 1, 1, 1. Red is easy. It's 1, 0, 0. Yellow is easy. 1, 1, 0. Cyan here is this. Blue is this. And magenta is this. Now, the only thing is I need to convert, because most of them are... Is it A0? I think it's A0. Or C0? C0. The ones that are not 0 or F. Okay, that's 0.75. That's convenient. So light red is C0, C0. Okay. So that's... Oops. That's going to be a bit manual, but that's fine. 0.75. Red here is correct, and dark red is... I think it's 0.7500. Yes, that's exactly what it is. 0.75, 0, 0. Next, light yellow. This is 110.75. Yellow is 110, and dark yellow is 0.75. 0.75. and 0. Light green is 0.75. I can just copy and paste, I guess. Green 0 and 0. Dark green 0, 0.75, 0. Light cyan is just the red is replaced by 0.75. Cyan is correct, and dark cyan is 0, 0.75. 0.75. That's a bit tedious, but we should be done soon. Light blue. And dark blue is going to be 0, 0, 0.75. Light magenta is just gonna be a 0.75 here, 101, and then 0.75, 0, 0.75. Okay, there we go. So now, what we can do is back here, we're gonna be able to use this library here. And we're gonna be able to make a bunch of, it's gonna be byte strings, however. So we're gonna need to make something. We might need to change our template again because it's taking a string here. Let's see what byte string has to offer. That's the wrong language. There we go. Is there lines here, or is not gonna be... Or is byte string too basic for that? No, we have what we need. Perfect. The only thing is this... I probably want to just convert that into a list of... introducing and eliminating byte strings. I probably just want to unpack them. That's probably the easiest. I'm surprised, however, that this doesn't require some kind of encoding. Is it because I'm explicitly in car 8? And would there be another one if I were to use... Ah, yeah, there we go. Unpack by definition would give me word 8. And if I make the assumption that it is all characters, I can use this one here and just do an unpack. And it will not handle Unicode, but since it's for our templates and not for user data, that is fine. So here we can change this to be instead a byte string. And this is lines of unpack. There we go. So now we can go back here and using the file embed thing, oops. This is going to be an image. And it's going to be obtained by doing a, if I look at template, make image. Or do I want all of my templates to be a function from color to, given that a lot of them will depend, I guess I can keep the ones that will be depending on a previous color. A function will not. So I guess a function I can just decide on a starting color. So it's going to be make image with red, let's say. I think we decided on green last time as a starting color. It's going to be fine. Make image with a color of read template. And this is going to be templates a function. Okay. Now, what we're going to do is, for each instruction, we're just going to be adding, extending the canvas of the function, and adding something to it, I guess. So it's going to be a fold over the list of instructions. Okay. Now, step is going to be where things get interesting, because this is where we're going to be adding instruction by instruction. Okay, so step is going to take the image so far and the instruction, and we'll return the next image. Okay. Now, I guess I need a starting color as well, because I need to know what color I was at the output of the previous instruction to know what I need to change for a given instruction. So this is going to need to be our starting color, green. And this is all going to return a new tuple of color and image, which for now I'm just going to say it's the same, so unmodified. I'm just going to open this here. Actually, for all of them, do I make that a separate function? Hmm. Can I do? Would that work? If I do a next color on this, no, I would need to do a actually flip next color instruction on this. It's probably not gonna work. Even if it does, it's not very elegant. Because that's just a let new color equals next color from that previous color. And oh, unless let me think about this. Now I think we want to return the color that should be used for the next. No, because I can't know that. Because it's always going to be based on the previous color. Okay, no, so I cannot. I will have to do something different. But I could, yeah, I could either get rid of this function altogether. I could just get rid of this function altogether, actually. And inline it here. Hmm. Let's just do that, I suppose. This feels a bit verbose, but I think that's probably for the best. We keep the separation of having this as a separate function, but we don't do it every time. We do it once with the let block here. Yeah, that's probably the least bad option altogether. Now, for all of those, most of them are not going to be special. The special ones are going to be push. Oh, unless we don't do the optimization here, we do it as part of the bytecode generation. And if we do that as part of the bytecode generation, then we don't have to worry about it here. We can just apply the template. That's probably the easiest. Which means rather than having push 1 million here, we would have already translated that push into a series of multiplication, addition, and everything as part of the generation. Or do we want to do that at this point? Maybe it makes more sense to make that at this stage. Because after all, as far as the bytecode is concerned, the thing we're doing is just a push 1 million. How it's translated into Pete instructions underneath is irrelevant, in the same way that the entrance is not a Pete command, it's just something we have defined because it makes sense for our image needs. So maybe actually, yeah, the optimization should be at this level. Okay, so yeah, push, entrance, go to, branch, call, return, terminate are all special. All of those others are just fairly straightforward. Excuse me. I guess switch is not. I guess. Can I remove pointer from the instructions? Can I remove pointer from the instructions? I think I can. In the sense that we should never generate a function that contains the pointer instruction. That should never happen. if we generate bytecode that contains pointer, something has gone very wrong. Because pointer is flow control, which is the thing we do. I think pointer and switch should never happen. And if they should never happen, maybe they should just not be in the bytecode at all. Yeah, I think pointer and switch should just not be there. We use it in the image generation, but it's not something that is in the result of a function generation. Yeah, let's remove them here, which means we don't have to handle them here either. Hopefully it's not going to be a problem. Okay. So now all of those are just take the previous instruction, get the color, insert one line of pixels of the correct thing, basically. So if we're coming from, I don't know, this thing, this one here, and we want to do a roll, for instance, we just need to compute the difference and insert one line, which is whatever the instruction template is, which we're going to make right now. Instruction that's going to be 1, 2, 3 white pixels. No, actually, because there might be things here. Those are going to be transparent pixels, 1 black pixel, 1, 2, 3, 4, which are the 4 pixels of our color, 1 black pixel, and 1 transparent pixel. Or I could just make it the sixth thing of the instruction and insert them at an offset, I guess. It's probably easier to just do that, however. Okay. So that's an instruction template. Which, given a color, makes an image. So for all of those, we're going to do the same thing, which is extend I probably want to make some common function, which is, okay, given the instructions we met, here's the template, here's the coordinates at which it should be inserted, here's by how much we need to extend the size of the current image, and make a function that does that for us. So this would be a bunch of calls to exchange, or rather insert, expand, expand current color, image, and then a bunch of things. Unless I actually make that a separate function. That way I can reuse, yeah, I probably gonna make that a separate function. This is gonna be append instruction. And I might, nah, that's fine. So append instruction takes a color, an image. Okay. And an instruction, and returns the new color, the new image. I think I'm not gonna bother with this. I'm just gonna import this a second time just to have image in scope. Okay, so this is gonna be a case instruction of or even a backslash case. No, because I need the instruction in scope to compute the color. Okay. And now we can define expand without having to give it everything. Oops. Wrong indentation. There we go. So I don't need to give it any of this. I'm able to just give it the size, the template, and whatever else I need. So expand is gonna need to take the number of rows to extend. It's gonna take the template to add. The coordinate is always gonna be 0. I'm gonna make all of my templates 10 wide. And it's going to be, okay, I expand by that many rows. Here's a template. And as a result, the only thing I'm gonna need is the starting row at which to insert the template. And that's just gonna be an offset, I guess. Probably just from the current, like a relative offset, I think. So if we look back at our image functions, just check this. So we want, was it canvas? Canvas size, okay. And this is an absolute thing, it's not a resize by. Okay, and I guess so expand is gonna do a canvas size of the image to make it bigger. And border resolution strategy is gonna be just a I fill or something. It doesn't matter really. Replicate the pixel at the edge is probably better. So let's just use that. So canvas size edge. The new dimension and the source image. Source image is image. And the new dimension is going to be the number of rows of image plus new rows. And the result of this, we're going to use the superimpose function. So superimpose coordinates thing above. So this is going to be a superimpose of the row to be computed with the offset. So probably a minus offset or something. And 0. And of the template. And the image is this one. Okay, so that's that. And now, how do we decide what the offset is? Is it just... I'm assuming rows are 0 indexed. That's not... Hmm. I'm assuming it is, but I don't see a clear confirmation of this. I mean, I don't expect it to not be 0. It's not said explicitly, but I would be really surprised if it were not. What gives me pause is this. This is 200 pixels on each side, and this function for row and column does divided by 200. So if it's from 0 to 199, this is never fully white. If it's 1 to 200, it's never fully black. So I'm not sure exactly. Yeah, I'm gonna assume it's like indexed at 0. That's what would make the most sense. So here the index is going to be, well, the first row after expanding is going to be the one that was at the previous size. So it is rows of the image minus the offset, which will be 0 for a lot of them. Okay. So for a pop, it's going to be expand of 1. Actually, I'm going to switch the offset. And at offset 0, insert an image, which is the instruction template with the current color. And that's going to be the same for all of those. Oops. So those are the easy ones. Now we need to do the complicated ones. So push is where we're gonna do the optimization, basically, of cutting it into a series of... Do we want to do that ahead of time, actually, or do we want to do it at this point? Because basically, this is going to be translating a push into a series of instruction and just going to call happen instruction all of them. So I guess for push, I can just do another fold L prime of happen instruction, actually, recursively, starting on previous color and the image, so unchanged. But the instructions on which we're going to do that are going to be the optimize push, except we need to have some form of... So we probably want to do that only if it's greater than, let's say, 8 or 12, because I guess we can always use... Yeah, I think up to 3 rows, 4 rows is fine. So I guess, let's say up to 4 rows. So if it's more than 16, so if it's less than 16, then we can do something specific. And otherwise, And otherwise, we need to decompose it into a series of more. Actually, it's a good point. I should probably not use int here. I should use some kind of restrictions like positive integer. I'm not sure what libraries would allow me to do this because a negative push makes no sense. And I guess I can rely on the fact that we're never going to try to generate from bytecode that comes from a third party source. It's always going to be bytecode that we have generated. So as long as we guarantee that our bytecode generator never generates a push of a negative value, we're fine. But we could probably. It doesn't hurt to have like if it's yeah. To have a sanity check here, but this should never happen, basically. Yeah, I guess a word. Well, the problem is like I want to have I want to be able to support a full in64 there, but only a positive one, but still 64-bit. So yes and no, because if I treat it as unsigned, then I would get values that are too big for the actual cell in the like if I get something that's greater than the max of a sign in 64 in a word 64, I still have problems, right? Yeah, basically I would like a unsigned word 63, which doesn't exist. So yeah, I guess just using int for now is fine. Because again, this is not something where we're gonna be at the mercy of user supplied input. So as long as we have the guarantee that our program never generates bytecode with something that's wrong, it's fine to just like error here because like okay, this is an internal compiler error. It's not that the user supplied something wrong; is we wrote something wrong in the compiler. Should never happen. I guess I could use one of those libraries that like provides wrappers around a type, so I can just like make some. I could even just make it myself with a smart constructor, and like okay, to construct a positive int, you need to supply an int that happens to be greater than 0 and less than, and then that's fine, I suppose. But I that's something we can optimize later. I think this is fine. And here, otherwise, we fold exactly that with the optimize push thing. So what do we do here? I guess I want to do this in 4 steps. That's gonna be the easiest, I think. It's a bit ugly. Because if it's less than 4, that's just an expand 1, 0. And I need to have a special instruction template for 1 to 3, I guess. Yeah. So push 1 template. It's gonna be reading this. Push 2. Push 3. And just for consistency, I'm just gonna add a push 4, which is just the normal instruction template. at least for now. So or actually, do I do something smarter than this, where push template takes an int, uh, amount color equals this of, yeah, let's do that. I guess this is just instruction there again. Okay. So this is an expand 1,0 with push template n of the current color. For 8, this is an expand 1,0 with push template 4 of the current color. That we expand with 1,0 and a push template. I could probably make that another function. Let's be less ridiculous than that. If it's less than 16, go push n, and I don't need anything else. Or just push, I guess. So push 1 is going to be, so I can remove this because that's ugly. Yeah, I think I'm gonna do the pattern matching above and not here, so I can get back here and have this again. Instruction is back to being push 1. Oops. And that's just instruction template that we keep just for readability. So push 1 is going to be a expand 1,0 of push 1 template. Of the current color. Push 2 is the same thing, but a push 2. Push 3 is this, but push 3. Push 4 is the same. And push n is doing that, is doing a push n minus 4 after doing a first expand with a push 4 template. No, because we want... because we want to have the first row of the push to not be the one to be the one that's incomplete, and then have the rows being full, because we use, for some instructions, we use the full length at the bottom there. Actually, is that gonna be a problem for some of the switch instructions? No, actually, I don't care. I don't care. The switch instructions, the color will do the thing correctly. So no, I don't care. It can be the last. Okay, so we expand by a push 4, and then we add a push n minus 4 afterwards. And if we ever encounter a push 0, that means that's impossible. Given the test we have here, that's impossible. So we expand the image by adding a line of 4 pixels, and we recursively then add more until we are done with our push. I think that's correct. Okay. So now we can rewrite this as push n here, and otherwise we fold the append instruction again, which is the same function, for the result of an optimized push. Now, how do we do that? Because we're gonna basically want to decompose it into multiples of, like, powers of 16, basically. So optimizing a push, if n is less or equal to 16, well, if n is if it's 0, it's the empty list. There's no need to do anything. If n is less than 16, that's just a push of that n. That's fine. And otherwise, we do a div mod, I suppose. So I guess it's basically pushing the mod and then multiplying whatever we had by 16. Hmm. Actually, Yeah, I think that's what it is. I think we want to get the instructions for doing the optimize push of the div, so the one that was after the division by 16 of a number. Then we want to add a push 16 and multiply. Unless D is 1, I suppose. So D will never be 0 because we've already filtered the case of equals less than 16. But I guess we could. Yeah, what I'm saying basically is if n is equal to less than 32, then we can do a push push 16 push n minus 16, which guarantees that here this d is at least 2, which means doing this optimize push plus push 16 plus multiply is the shortest thing to do. And now we can do plus push the remainder unless it's 0. So many tricky cases. Multiply, and after that, if r is greater than 0, then push r add. Is it called add? It's called add. Else nothing. This is gonna require some testing, but I think this is fine. Okay, so we've handled push. Now we just need to handle the entrance, which is gonna be an expand. This is something we need to keep track of. Our fold needs to keep track of where the last entrance was, because if we ever encounter an entrance that's too close to the previous one, because the entrance has this strip of things on the right here. Excuse me. So if we are an entrance that's too close to the previous one, we need to insert some blank spaces to make sure we don't overwrite the previous strip. So we need to be 1, 2, 3, 4, 5, 6. We need to be at least 6 pixels after the previous one. That means we need to keep track of where the previous. We need to know how many pixels we're in, and we need to know what the previous entrance was. Where we are is easy. That's the number of rows of the image that hasn't changed. That's our offset. The question is, therefore, it needs to be at least 6 above the previous one, which I'm almost going to start making this into a statement at this point. But so at first, the previous entrance is at like -10. There's never going to be any problem. But int last entrance. Do I have the problem with exits as well? Yes, I do have the problem with exits as well. Although I guess... No, I do have the problem with exits as well, where I cannot make just an exit without checking before that I'm not at least 2 pixels further than the previous one, 3 pixels further than the previous one. So, do I make that a state instead? Maybe that's better. So this is gonna be a run state of traverse append instruction. And with the initial state being this thing, unless I make an actual structure for this, maybe that's going to be better. So let's be verbose. Oh, I forgot to add template Haskell to this file. And I'm gonna import immediately control.lens because I'm gonna use it in my state monad. So an assembly state is the current color, which is a color. Last entrance, and maybe I make that a maybe int. Last exit, maybe int. Actually, I could use data monoid. I think last is a monoid. And it gives me a maybe A. And that gives me the useful thing where I can just concatenate any previous last with a new last, and it does the right thing. So this is a last int. Next, what do we need? The current image, I suppose. Which I'm gonna bring to the top here. Okay. Initial state. Initial state is gonna be an assembly state with the given color and image, and just the empty monoid for both of those. Okay, so now this is a run state of traverse append instruction with the initial... I'm just gonna keep this actually. Okay, there we go. Append instruction, we're back here. And now I can rewrite this. This is no longer all of this. This is something that takes an instruction and... Actually, I don't need to put the image into... There is... Google. I want a function that given some value A and a function from... I want a fold, but basically a monadic fold. Is that fold M? That's fold M, yeah. Yep, that's fold M. Fold M upon instruction is correct. But I need to give it upon instructions. And the start is going to be the function template. And the instructions. And the initial state green. And that way I'm going to remove the current image from the state. And instead it's going to be what's passed. Maybe it makes sense to have also the color like this because every step will modify the thing, so maybe carrying it as the state. Hmm. Hmm. Or does it make more sense to just have it all as the state and that's fine? Nah, I think having it all as the state is a bit more consistent. Let's keep it that way. So this is traverse upon instruction of the instructions. And now this takes an instruction and this returns. So here I can do that, and here I can get the result, which is the current image after doing an exec state. I'm just going to rewrite it that way. Nah. Okay. So now upon instruction is something that takes an instruction and returns a value in the state monad, in which the state is an assembly state, and the value we return is just a unit, since we're going to only be modifying the state and not doing anything else. I think this is all remaining the same. This becomes a traverse again. Even a traverse like this. Now expand, I can do a few more things. Oh, I need to give expand a new color as well. No, wait, no, I have it with the current color. So this needs to do, it needs to get, I no longer have this because it needs to be computed from the context. Okay. So I get the current context, which is our assembly state. I don't need to do that. I could just get it. I could do a previous color will be a use AS prev color or current color. And prev image is the image that's in our state. The new color is gonna be this step thing here. the new image is gonna be this thing we were doing already. And the result is going to be we modify the current state so that I can use the lens for this, I suppose, again. Current color, current image becomes this new image in the state. Current color becomes this new color. Okay, and that's it. We've gotten the current ones from the state, computed the new ones, modify the state. I guess now I have to rewrite those because this is no longer correct because expand is just something that modifies the state. So now this is no longer this, this is this. Wait, no. That was correct. It's this one that becomes this. It's a push n minus 4, then expand this. There we go. Oh, except I don't have. Oh no, this doesn't work. Ooh. This doesn't work because expand modifying the color, I would be. No, that doesn't work because I would be pushing a new row of values. So this doesn't work. Also, I suppose this template here doesn't know the current color and therefore needs to be given here the current color. So this becomes this. Now, I'm guessing this is mostly correct. The only thing is we need to make sure that between this push and the expand, we reset the color to what it was. I guess that's the downside of doing it with the state monad is here I have to do some extra, or I could just rewrite some of the. I could rewrite some of expand, but I guess it's the easiest. It's why are you unhappy with some of the alignment? Because I forgot the closing parenthesis here. That's why. So here this is gonna be get the previous color from the state, do the push of n minus 4, reset the current color, and expand with the push 4 template. Yep, that should work. Okay. Do I even need, actually, do I even need the offset argument, or is it just the size? No, I need the offset because it's not just the size of the thing. Okay. Okay, so now we are at the point where we can start making some of the advanced constructs here. So we need actually to make that's instruction. I need to make push 1 to push 3, which is going to be the same thing as this, except there we go. Push 2 has 2 zeros. And push 3 has 3. There we go. So now we need to make an entrance. What's an entrance? That's going to be this block here, which includes this strip here. So what that means is whenever we encounter an entrance, the address I don't care about, this was part of the linking process, but I no longer care what the integer pointer of that thing is. What I need to know is what we need to do is basically we need to add an empty line for each. We need to add an empty line for each, for the value, yeah, until this value is because the current row is using the current image, and we apply the image.rows function. And basically, if this is not 6 more than the previous one, then this needs actually 7 more. Because here, this color here, it's a starting color, and therefore it needs to be independent from what comes before. So we need to always have 1 white pixel here. So that's 3, 4, 5, 6, 7. Actually, there's probably a when just. So basically only execute a monadic action when the value is something, and I think that is in extra. Control monad extra. When just, perfect. So here, when just. Actually, is there a when just m? There is. Maybe I want to do when just m of. get last of uses as last entrance get last. There we go. So when that's a just value, so there is a previous entrance, then what do I do in this case? I think I just do for 1, 2, current row minus previous entrance minus 7. So if my previous entrance is, no, that's wrong. That's wrong. What do I want to do? I want to compute an integer value, which is the amount all the way to, so it is from previous entrance. Let me think about this for a second. It is from current row minus 7 to previous entrance, which means if we are already past the previous entrance, like if a previous entrance was at 1 and we're at 8, we're going from 1 to 1, and that's inclusive actually, so probably previous entrance, so probably a minus 6. Because we need to be at 7 further. So if we are at 7 and it was at 1, this is 1 to 1, that's 1 line, so we add 1 line, so now we're at 8. We are indeed 7 later. If we are at 15 and the previous was at 14, we go from if we are at 15 and it was at 14, we're gonna go from 9 to 14. We're gonna be adding 6 lines. I think that's correct. Yeah, I think this is now correct. So for this range of values, we just completely ignore the value. And we expand 1, 0 with blank line template. Blank line template doesn't need a color. And that's, oh no, oops. There we go. Okay, so that's the entrance. Rather, this is expanding from the previous row, and now we can insert an entrance, and an entrance is going to be, that one is going to be tricky. So This is 2 rows of 8 transparent values, or at least white on this side. No, it needs to be transparent, I guess, because we could have an entrance right after an exit, which will actually be the case every now and then. So this needs to be transparent. So 1, 2, 3. 1, 2, 3, 4, 5, 6. Our start color 0. Then this is a push of 1, because what we do here is we push 1, we do a subtract, a duplicate, and a not, if I remember correctly. Basically, is this 0? So starting as red, we go 1 darker, that's a push. Then we go from dark red to light yellow, that's 1, 1. 1 darker, 1 step in hue, 1 darker, that's subtract. Because subtract, I suppose, removes second value minus the value, so we do indeed the -1. Then we go from yellow to, this must be light magenta. So that's green, cyan, blue, that's 4 steps in hue. And we go from light to light, so that's none, so that's duplicate. To duplicate the values on per stack, which is the current address. And I'm guessing we do a not. We are going from, this is a dark green, so we're going from light magenta to dark green. That's red, yellow, green. That's 3U and 2 lightness. So that's, wait. What? We are on light magenta, and we're going to, oh, dark green. So it's 3, 2. Huh. Why are we doing a switch? I think that's wrong. I think that's supposed to be a not, which should be 2 steps in hue, 2 steps darker, which from a light magenta would be a dark yellow. Unless this is, oh, unless this is a dark yellow. Okay, not a dark green. So this is indeed a not. Okay. And after this, we go from dark yellow, which looks a bit green to me for some reason, to what I think is a light blue, which would be 1, 2, 3, 1, and should be a pointer. 3, 3, 1 pointer. And since we've just done a not on a value, if that value was 0, that value, the new value is 1, pointer by 1, we rotate 90 degrees. If it's 0, we don't rotate the pointer, we continue. So yes, that's what it is. Okay, so let's represent this. So after this is going to be a push. Let's go back to template to have... So from the starting color, this is a push. From the starting color, from red, this is a light yellow. So that's 1, 2. So that's star. From the starting color, this is light magenta. So that's 5, 2. Let's see. Then this is dark yellow. So from the starting color, this is 1, 2. Sorry, 1, 1. Oh, I need to be careful. This was light magenta, so it was 2. This is dark, so this is 1, 1, which is minus. And then from the starting color to light blue is 1, 2, 3, 4, 2. It's I. Okay. The starting of the offset is, so we have 3 of them before and 3 of them starting here. Actually, we probably just want the 6 because we probably want to always insert a white line, but that counts as a 7, I suppose. Okay, so we always want to be... No, yeah, I guess we only want to be at 6 further than the previous entrance because we always want to add a white pixel so that things flowing through the entrance don't execute an instruction. So here we can reduce that to 5. And here, so we're going to have one row of white alongside the third pixel that we always want to have. Then we are going to have this complicated mess. So from the starting color, this is 1 further, because what we are doing here, we have just done a pointer to enter here. This is a dark blue from a light blue. This is a pop, so we're popping the address because we know it's 0 at this point. Then we have a light blue from a dark blue, so that's a push, so we're pushing a 1. Then we are going from a light blue to a light green, which is 1, 2, 3, 4, 0, which is a duplicate. So we are pushing a 1 and duplicating it. Okay. Why did I do that? Then light green to magenta. 1, 2, 3, 1. No, that's probably... yeah, 1, so pointer. So we rotate 90 degrees. Why do we have a duplicate then? What do we do? Magenta to cyan, that's no change in lightness, that's purely a 1, 2, 3, 4. Let's duplicate again. So we duplicate, we have a second 1 on the stack. This must be another pointer, which is probably actually not required. Because this would... oh, but it's not always going to be... no, it's always going to be black above. So I don't need that actually. I could simplify this. Because then this used the pointer to rotate. But, and then I suppose from dark red to light cyan, 3, 1, this is again a pointer, I suppose. Yeah, it is again a pointer. I don't need that, I think. Actually, no, I do want the pointer to the right here because I want to always reset the second pointer, which is the one that dictates if we go left or right at the exit of a block of pixel. I want to reset it to always being... it's fine with the pointer. I don't think I need this. Which means an entrance doesn't need to have a white line because that line is going to be white. The only one I need is going to be the one here to rotate in this direction, and then it can bounce on the black pixel here, can bounce on the black pixel here. Oh, actually, unless I want to guarantee that it finds... No, I think I want the pointer here. So I think I need to have... I think the push duplicate pointer here is correct. However, I don't need to have this duplicate pointer here, and I can just instead... I guess it doesn't hurt. Because I want to enter this block of color that does the pointer, so that there is this block of color with right being here and left being here, so that it always, like, sorry, left being here, right being here, so it always picks the left thing, so that I know it's left aligned for the rest of the function. So I probably want... yeah, and if this needs to be a pointer, then it needs a color transition. So this needs to be not white. So that's why it's done like this. Okay, so that makes sense. So we can keep this. So what I've written so far is correct. So after here, we have the light blue. This is dark blue. So compared to light blue, it's just 2 darker. That's incorrect. Oh wait, no, because red is our starting color. So yes, 1, 2, 3, 4, 1, 2. So it is indeed 4, 1. So it's R. Next, we're back to light blue for 2 pixels. Then we are at light green, which compared to light blue, which is 4, 2, is 3, 2. So that's S. And then we are at magenta, which is 5, 0 compared to our starting color. So that's C. Then we are at cyan, which compared to is just 4, 0, so that's D. Then compared to... Is that correct, actually? Compared to red, this is 1, 2, 3, so that's wrong. That's this. And so magenta is wrong as well. Right? 1, 2, 3, 4. Oh no, that's correct. No, I just skipped over blue. And then we have here, which is just a darker version. So it is just this. Finally, we have 2 black, 2 white here. And this row is 4 of the same, which in this example is light cyan, which compared to our starting red in the example is 3, 2. And 3, 2 is S, which is consistent with, which is not consistent with this. This is light cyan. Compared to red, this is 1, 2, 3, 1, 2. So it is S. So why do I have an S here, which is wrong? Because I have I here, which is 4, 2, 1, 2, 3, 4, 1, 2, light blue. That's correct. Then I have 4, 1, which is dark blue. Yeah, then I'm back to having 4-2, which is light blue. And this should be light green, which compared to our starting color is 2-2. I might have gotten it wrong, because 2-2 is this, yeah. Okay, so that should be the entrance. And the line at which we start is this line here. So that means our offset is 2. So we do this, and then we do an expand. We're going to be adding 1, 2, 3 lines, 4 lines, because those two we overwrite. So we expand with 4 lines. Our offset is 2. And our template is entrance template. Okay. What next? What is a go-to? I don't think I have an example of a go-to in this, which makes it a tiny bit more complicated. But a go-to with an address, a go-to is not a function call. So it's not, I don't have to manage any of the stack. A go-to is just pushing the address and going there, basically. So I guess a go-to is wait, I guess I don't need to do this distinction here. Optimize push will do the right thing for 16, so I can just... No, wait, no, because I do the traverse, so this needs to be handled here. Okay. But as a result, I think this is correct. I can just do traverse of append of instruction of optimize push of this address. So I'm pushing the address to the top of the stack. So this expands my stack by all the pushes I require. And then it's just a matter of inserting a... It's just a matter of inserting the template that allows for the thing to exit, which is just basically this, a white pixel here, a black line in here, and this thing here, so that it does basically rotate and go to the bottom of the image and then come back here, which for the first function is not needed, but yeah. Okay. So let's do the exit template, which is going to be a lot simpler because it's basically we force a white pixel on the previous line. Actually, we need a few more lines. We need 2 more lines before that. Because we need okay, so that's this little template here, pattern here, that allows the thing to rotate and go to the bottom of the image and then come back up with white pixels. One white pixel in the wall here so that the thing can escape. And then the new row that we're inserting, which is just a bunch of this is annoying. Okay, there we go. Which is just a bunch of, which is just a large wall, basically. Yeah, we override. No, actually, this is wrong. This doesn't need to be. This is just white. Okay. So yeah, we don't override anything before, but we make an escape hatch here so that this can do this. Actually, I guess I could force this, although it's always going to be the case. Just for readability, I can make it like this. There we go. Now the template is a bit more obvious. Okay. An exit template doesn't need color. Oh, I guess I don't need to reset the color after. I was thinking of like after an entrance or an exit, always resetting to a given color so that every new block of instruction starts with the same thing. But I don't need to do that actually. I could just keep the previous starting color and just iterate from there. That might be actually better. Yeah, let's do that. So I'm not gonna override the current color whenever we touch the exit or anything. That way we're just gonna have more variety in colors. Okay, so that's the exit. So when we encounter a go to, which is not a function call, we don't need to push the return address to the stack. Oh, that's annoying. I have modeled the bytecode with the idea that calling a function is a separate instruction from a simple goto, and that's because we need to push the return address on the stack. The problem is that the return address must be pushed before the arguments are pushed, which means basically the bytecode generation will be doing all of that. And what that means is that there is no reason for me to distinguish between a goto and a call, because that's something that will only depend on how the bytecode is generated. However, that means I need to have a push, which is a push of an address versus the push of an int. So I need to revise my linking, is what I'm saying. Yeah, yeah. I need to revise. I need to revise my bytecode and my linking. That's fine. Let's do that. So there's a push int and there's a push address. There is no call that doesn't exist. Branch is the switch. Yes, okay. So now let's go back to linking. So now I need to distinguish between push, this is the push int that remains unchanged. And now I need to also handle the push address. Which during the linking phase is transformed as push being applied on name lookup of the name. Okay. Call no longer exists because we have go to branch and push address. And to an extent, I might not even need the go to because go to is just. I already have push address. So go to is just an exit basically. Yeah, I think I don't need that anymore. I need branch because branch is specific. It's a weird set of instructions, but there's just the go, the exit function basically. And that doesn't need any special case. I can still call it go to, but it doesn't require an argument anymore. Okay. So go to does not require a thing anymore. We just have an exit. Well, no, so we have entrance go to branch. Yeah, I think that's all we need. Wait, why do we have return? Yeah, return is no longer required either. It's just the same thing as go to, basically, which I guess is a better name than return. Return is a better name than go to. I'm gonna keep return, which is basically leave the current function to go to the current address. Okay, so now we need to change our linking as well. That's already done. That's what we've already done here. Okay. And now we can go back to the assembly. So now we need to distinguish this is, as far as we're concerned now, those are the same thing. The distinction between push int and push address is only useful for the linking phase because an int is not affected while an address is. So push int is going to be exactly that. So maybe I can do. How do I deduplicate this is my current question, because it's going to be the same thing for push int and for push address. To the point where I guess we could, during the linking phase, replace all push addresses by push int, And then that actually, wait. No, because branch needs it. I was gonna be thinking, can I replace address by void? But no, I cannot. Yeah, okay, let's just handle it this way for now. Not very elegant, but that works. Now, we no longer need this. Good, and now this is called return, and this doesn't have an address. And now what we do is going to be the same thing as for an entrance, except here we want to be not 7 further than the previous entrance. We need to be if we have to add more lines, yeah, I think we are assuming that the background of the canvas is going to be white. Yeah, I guess we have no choice. Okay. And here, either the last instruction is here on this line and we just rotate right, or it's white, but we're going to be just bouncing here to the right, which is fine. Yeah, it's fine. That should work. I guess I could always have white and then a color here just to make it more. Like I could have something like this. Where this is always, so this is the previous row, whatever it was. Oh, that's pretty neat if we do that. If it's always previous row blank some random thing from which we exit here, is that we don't need to care about the last exit anymore because we're always going to be adding enough lines that we don't need to care about the previous exit, which makes a lot of things easier. There is no need for last exit, which means we don't need to do this when just m thing. This is an expand. We add 4 lines. Our offset is 0 of the exit template. Given how expand works, actually, I'm going to need to change all of those to all be function from color to image. And I think I'm going to make a helper function to simplify this. Function template is make template of this. And make template. That's going to be annoying because of the use of template Haskell. Those are going to need to all be above or in a separate file. Make template is going to be given a byte string. Make a function that takes a color and returns an image. And make template of the template T and the a template and a color is something that makes an image with that color of that template. So I guess it's just a flip make image. Which begs the question, why? Wait, what am I saying? No, that doesn't work. This is a make image color of read template of the template. There we go. Okay. So this is now and I'm tempted to do something where I put them all here, instruction template, or I could even do a thing where yeah, I think I'm going to do something slightly different. I'm going to go back to template. And I'm going to make the templates in their own special file so that I don't need to have template Haskell anymore in this. I mean, I'm going to need to have it for the lenses, so I can just leave it here. But I can move the templates here. And here I can do a, I never remember the pragma. Is it options underscore GHC? Options underscore GHC. Yes. And here I want to disable warnings for missing signatures only for this module, because here I can move this here. And I'm going to need to move also, I need to copy this. I probably only need image. Okay. Make template is still required, but now I can just say function template, instruction template. And I just do that, and I don't need to give their types for just this file. Almost tempted to generate it with some kind of template Haskell because it's very repetitive, but that's fine. It's almost tempting actually. I could do a thing that for each template file in the template thing creates a top level declaration that has the name of the file template, or template the name of the file, and is, this would be complicated template Haskell, so I don't think I'm going to do that. It's tempting. But maybe I'll do that next time because I don't want to like add another thing on the stack. Maybe next time we'll clean this by making it auto-generated at compile time rather than having to make the list manually. Okay. So now we're back here. I can add templates. Now I have access to all the templates. Perfect. And they're no longer in this file. Okay. The only thing is I am going to need, this is going to need to move at the bottom because of template Haskell. That's fine. And here I am going to need to add make lenses. Oh, actually, I don't. I could do this. Because only what's here needs the lenses, so it's the only thing that needs to be after them. So I can just make the lenses of assembly state at that point in the file. Okay. Now we're back to append instruction. Return is just expand with the exit template. Call no longer exists. Return is already done. Now we have 2 templates left to do and we're done. We have branch and we have terminate. So let's do that. I'm out of drinks. Maybe I'll take a break to take a drink. So branch is the most complicated one. Branch is this, basically. We have a value on top of the stack that we're going to do a not on to guarantee that it's 1 or 0, basically. So we do a branch if not, a branch if 0, basically. And we do a not, it gives us a 0 or a 1. And based on that, wait. This use of expand takes the next color based on the instruction. So we always reset, we already do the reset of, unless I change this to be, to not modify the color, which I think I might. Yeah, okay. So, oh, actually, this still contains call. It contains goto, which no longer exists. It contains push, which is push int and push address. This doesn't reflect the changes we've made. There we go. Entrance, branch, return, terminate. I think that's all. Wait. No, that's correct, yeah. So, branch. We need to do a not, and then we need to do a switch. Since our functions are made so that we are always left align while going down, we enter the switch block left align, and if the not of the value is 1, we do a switch, which means we become right align, and we enter this thing, which I guess must be a pop of some kind. We must pop the condition, I suppose. I guess it must be a pop in both cases. This is from light green to dark green. Yes, it's a pop. So that means we are always popping the condition after a. Yeah, I guess an invariant that we're gonna need to enforce during the code generation phase is that a branch always does. I guess I could enforce that by doing a duplicate at the entrance of the the. Yeah, I could do that. I guess. The only thing that's ugly is that it's gonna be a very big instruction because I'm gonna need to duplicate the condition. Or do I not want to duplicate the condition? Because maybe that means that I have to do. Because if I duplicate the condition, that could mess up the stack. Yeah, I guess I have to trust. I have to trust for stack reasons that that the stack was in the correct form before, and that whatever the value was, it can be. Wait, it is gonna be destroyed anyway. So why do I need to pop here? Because when I do a not, it replaces the current value. It doesn't duplicate it. I do the switch, it consumes the value. So whatever was the condition, it has already been removed. I don't need to do a pop. Oh, I guess the pointer the yeah, this can just be the pointer instruction. I guess this was a manual optimization. The pointer instruction can just be all 4 pixels and it will yeah, yes, that's what it is. Okay, so we don't need to do anything complicated. We don't need to do a pop. This is just duplicate. This is just not switch and then an empty line. So it's going to be very similar to exit. Except after the previous line that's here, we need to do a not on it. And since this instruction doesn't upgrade the next color, our starting color 0 here is gonna be the one of this line. So we need to put a not here, which is this symbol, if I remember correctly. 2, which is not, yeah. And then compared to a not, we need to do a switch. We need to do a switch, which is 3 hue to darker. But compared to something that was already 2 and 2, so that's 5. So that's 5 steps in hue and 4 in dark, which is the same thing as 1 in dark. So 5, 1, which is an out number. And this has 2 black blocks here. So if the pointer was at 0, we continue straight here. We stay on the left. Otherwise, pointer switches to the right. We hit this wall. We rotate 90 degrees. Pop, 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 pop. And then we're back to the control flow outside the function. Okay? So that's... And I saved it on the wrong file. This is... This is branch. And this is exit. Okay. So that the good news is going to be fairly straightforward because branch. Oh no, branch has the address as well. Or does branch not have the address? It's probably easier. Like, I don't need to bundle a bunch of things. I can just let a lot of the code generator do that properly. Or, like, making sure that the stack is in the right shape is not the responsibility of this part of the code. Maybe branch doesn't need the address. It can assume that it is the top of the stack, and that's fine. In which case, we can change the bytecode, because otherwise I have to include a push of the address, a roll to put the condition back on top, and everything. While actually the generator could realize that we can push the address always ahead of time because the condition is fixed and optimize that for us. Well, if we do the push at this stage, the optimizer can't kick in. So yeah, no, we don't want to do that. So I think branch doesn't need the address, and now I think we can do something smarter. We can replace our linker. And I might want to change this. Because now our linker is no longer going from like an instruction with a name to instruction with a pointer. It goes from an instruction indirect to an instruction resolved or something. And indirect is when we have text, and resolved is when we have void. And the nice property of void is that it has no constructor, meaning it is impossible to create. Wait. Yes. No, that doesn't work. That doesn't work because entrants need to still exist in the resolved. Okay, ignore this. The idea of what I wanted to do, which doesn't work, was I wanted to change this so that the address here was void, which means all push addresses would no longer exist after linking, and we would only have push ints. But I guess, however, I can do something like this. Linker phase, which is either unresolved or resolved. And we have a class phase types that takes as an argument p a linker phase, where we have the type, which is push address, which is a type. And we have the entrance address, which is also a type. The instance of phase types of unresolved is when we have a push address of unresolved resolved is text, and maybe it's gonna be name or something like this, something that's gonna be a bit uh, more specific at a later point. But for now, text is good enough. And the entrance address for unresolved is text. However, when we are done resolving the thing and we're done linking, the types after we have solved, resolved the linking phase, the push address is void. And the entrance address is unit. There we go. Which means now linking, I can change a few things. Name pointer no longer exists. The linker state is hashmap name to int, which is the address. Text in here, although I guess I could keep name and pointer at some point, but nah. Okay. And this is in section unresolved. And at the end, when we're done with the linker, we have an instruction resolved. And now that means we only have branch no longer has a name. So branch is like the others. Pure branch, there's no need to do anything anymore. The two only ones for which we have something to do is push and entrance, because push of an address needs to do a name lookup, and a push address becomes a push int because it is impossible to have a push address of void. And an entrance becomes like assign doesn't need to return the address anymore. That's fine, because the entrance that we return has just a unit, which means we only have one lookup, one assign. I can remove those functions. So target is this, or pointer, I guess, but that's fine. So push int of the target. And entrance is, I can just copy paste this here. Get the current address, increase the entrance count, increase current by 1. Which I guess, no, because the entrance count and current are, entrance count is for this function only. So I need both increased by 1 separately. I register the name and the address, and I return an entrance. There we go. Which means now if we go back to our assembly code, we no longer have to handle the push address. The only thing is, since it is lazy, I think if we don't handle the push address case here, the compiler is going to complain because an unevaluated void value could still be something. Specifically, the only thing it could be is bottom, as in an error, because there is no valid value of type void, but there are valid expressions of type void, the ones that return a panic, basically. So it's gonna complain if I don't handle this, but in the case of a push address, we can just immediately error here because the type system doesn't allow this to happen. This value here would be an error, basically. And this is not, so those are not instruction pointer, those are instruction resolved. Okay. So push address, just an error, cannot happen anymore. Push int handled properly. Entrance, we can just ignore the thing because now at this point it's just a unit. Return branch. Branch, we've done the template, so now it is exactly the same thing as return. It is just one expand here. And this is expand with the branch template. Actually, I've already done some code that does that. The only thing is that I would need to do the embed file, which is... Yeah, I'm very tempted to have to do a tiny bit of template Haskell to just automate this part, basically, at some point. Um, but not tonight. And terminate is the last one we're going to need to do. And terminate is this block here, and that's basically the end of the execution. This is when we encounter a panic, basically, and it's gonna have to be inserted at the end of main and in every error function, I suppose. Although I guess I could also make my code generator generate last function, which is always just terminate and nothing else, so entrance terminate and nothing else. There's no good or bad reason to do either. I think, however, I want to make it slightly different from this template here, because here, since it extends one to the left of the function block, it would block, if this were a normal function that happens to have a panic in the middle, has been in line, it would block this path, which is the one that functions take when they do a return and go back to the address loop, basically. So this needs to be a bit smaller, but the logic is the same. The logic is basically this needs to be a line, and I think red is pretty nice, but it's going to be whatever color is next. And this is going to be, unless I force it to be red, actually. And this is always going to be basically a line that has no next line, because when it enters this red block here, it has nowhere to do at the bottom. It tries to rotate 90 degrees. It has nowhere to go here on our left, its right. It rotates 90 degrees. It cannot go anywhere on its leftmost pixel or rightmost pixel. And it rotates 90 degrees. It cannot go anywhere. I'm just like, okay, there is no direction for me to go. I'm done. We can probably make this a tiny bit smaller. So here, since I want this to be red, I'm gonna go back to, is it bytecode? No, it's in color. I think for terminate, I'm always gonna say that the result is red. I like it. I want it to be red, I think. And as a result, let's write terminate. Terminate template. So we want those three to remain white or transparent or whatever they were. We don't want to modify them. Actually, we could force them to be white, I think. All templates, actually, probably. Since the exits never, yeah. So I think it's fine. And we just want to have, I think we can make it a bit smaller. I think if we do no, that's a complication. We can't extend to the right either, because the problem is we need a function could panic and have further entrances down another branch. So we cannot just also erase what's on the right like we do here as well. So we need to make it fit within this six counting the walls boundary of a function. And I guess the easiest way to do this would be having some white thing here. It can enter here. And then we have here 0, 0, something like this, 0, 0. I guess for all of those, I could actually put like dot here because we're never going to be overwriting a previous entrance. The next entrance will override the previous thing. So I guess it's probably going to be a bit easier to read. So yeah, we want a white line always, because we don't want this to be executed as an instruction, although it wouldn't hurt, but it's still better not to do that. Then we guide it here to the end so that it rotates 90 degrees and enters this block here. And then this block here has no escape. Yeah, that should be fine. So this is 1, 2, 3, 4, 5, 6. Okay. And last but not least, here for terminate, we expand by 1, 2, 3, 4, 5, 6. Offset 0. There's no need to go higher than the current line. And that's the terminate template. Okay, so that should be... We should be at a point where we can generate the image of a function. We don't yet assemble it into one big image. So I guess I'm just gonna... Like, it's missing one thing. I'm gonna do an add function here, which for now, so add function is going to be... I'm just gonna leave it as underscore. It's gonna tell me what it is. Add function equals undefined. Let's try to compile this now. So we haven't been compiling once in 3 hours. So something are gonna be... first, this image library we were using is not in stackage. So we are gonna need to add it to extra depths here. Oops. Can I just say that? Or will it be unhappy if I just say that? Yeah, okay. It needs... because it's a dependency of... Maybe I should have tried to look for a slightly more common image library. That's fine. Okay, so now we're installing all of our dependencies. That's gonna take a while. At least I'm no longer running OBS on this machine, so... While it does that, I'm gonna go back to my templates. Because I think for most of them, I can force every... Yeah, I can specify what pixels are supposed to be because there's only one template in which I overwrite previous things, and that's entrance. All of the others I don't, which means I can always write ahead of time that this is white. That avoids having white space at the end of the line. That's better. Entrance is the only one, and it's a offset. It's in a offset of 2, I think. Yes, offset of 2. So those 2 lines need to be transparent, but those can be white because they are newly created, and I can say what they are. Wait, blank, branch, entrance, exit. There we go. Function. Instruction, likewise, I can add this, push 1. Okay, push 2. Okay. And terminate. Okay, so now we should never have the problem of transparency being applied to pixels that were undefined, meaning we don't care about what the background of the overall image is. We will be putting the right pixels for what we need, basically. Which means that as far as we're concerned, except for some very specific pixels outside of our function, we could have the background pixels of the generated image be whatever we want. It would not matter as long as the path that we take through the image remains white. Everything else could be anything. So we could like insert background images that we want, like an image of a frog or whatever. The background would be fine. This is a lot. So many warnings. And yeah, as soon as this is ready, we can try to generate an image of a function. We don't have yet something that makes a program overall. Aha. Fantastic. The image library doesn't seem to be compiling. Let's see if we, by rebuilding, we only get the one error. So those are warnings so far. Those are warnings. A lot of those warnings are compatibility issues. So I'm assuming this library has not been tested with recent versions of GHC. Doesn't tell me that's a warning. Ah, no location info. Simplifier ticks exhausted. What? That is fascinating. That's an area I have never encountered before. Okay. GHC is struggling to compile this image library. How do I give this for a package? Those are GHC bugs. Could it be a GHC? Okay. Um, let's see how I can give options for the compilation of another package. Cabal flags can be set for each package separately. Perfect, that's what I want. And is that in... That's probably in the stack.yaml, I suppose. So that would be here. So flags for hip. Oh, it's not. That's not. No, it's not a cabal flag. That's a GHC option. That's different. Flag. Can GHC options? There we go. GHC options in some package. And I'm assuming that's within. So this is for non-project specific. So what file is that? Okay, it's still in the stack.html. Okay, perfect. So that's GHC options. Or apply GHC options. Yeah, okay. So I need to do that. I need to do GHC options. For this library, I need and what is this? Equals I don't know, 1,000. And let's see if this manages. It would be a bit annoying to like spend a few hours making all of this logic and then having to change the image manipulation library at the end just because it doesn't compile with current version of the GHC. That would be a tiny bit frustrating, but you know. Let's see. That's an error I had never seen before. So many warnings. Actually, I could have a look at when it was last updated. (2020), so it's not that old. Aha, that was enough to fix it. It did compile. So now we are compiling my project and finding errors in my code. That's better. That's easier to fix. Conflicting type family declaration. That's because here this should read resolved. The use of data void is unused because I probably already import void in my prelude. That's the case. I should probably actually just also import that I can type in my... actually, this might conflict with something I name type in another context, so maybe not. Pointer no longer exists. That's an int. A branch has no argument. Pointer and switch no longer exist. Name is text for now. Unresolved. Name is text. I did not list byte string as a dependency. Instruction unresolved. Um, mm, 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 mm. Is it the right syntax? I think it is the right syntax. Expecting, or is it just because I have not? It's just because I have not specifically said instruction. Yes, I think I forgot to do that. Yes, I did not fix this. Instruction here, this is a phase, which happens to be a linker phase. And this is now a lazy push address of the phase. And this is now a lazy entrance address at that phase. Oh, of course. And now I need to say that for this to be show, I'm gonna do it here. Deriving instance if show of push address of P and show of entrance address of P, then we can derive an instance of show for instruction of P. There we go. Cannot derive. Yeah, I guess those are no longer functor foldable traversable because they're no longer functor of values. That's correct. So this can go away. Okay, I don't want to use undecidable instances for this. So I'm going to rephrase this here. This class has two constraints. And now I can move those two constraints here. And now this means there are phase types of P. There we go. Oops, I didn't save. Okay, that compiles. Push doesn't exist. This is push int. Yeah, I don't know what this template pixel is left here. I'm gonna add a deriving show for debugging purposes. For consistency. Expecting more arguments to image. Okay, so we're gonna need to... Okay, so the type image in the library is not just an image. It is parameterized by a bunch of things. It is parameterized by the type VU Victor Unboxed, I suppose. And this is... So if I use RGBA, what is E? What is E? I guess it depends on the color space. So let's see what a color space is. It doesn't depend on the E, that's interesting. So what is an elevator? Aha, this is where I select what my values are. So I could change back all of my things to be actually word 8, which I might do. I think this is better. which is it in assembly or is it in template? It's here in template. Here in template, I'm therefore gonna change all of this. Where do I want to introduce the notion of image? And probably here in template, since this is where. So an image that I'm gonna be using throughout this is gonna be image as it is defined in that library, using unboxed vectors as the storage underneath. The color space is therefore RGBA. I get one of those spams every time. Yep, there we go. Sorry for the delay. So we are using a vector unboxed for the underlying representation. The color space is RGBA. And the type of values is going to be a word 8. Okay. Which means here I can use the make image that doesn't specify the representation because it's going to be obvious from context, because this make image is returning our image type that already specifies everything. And here I can therefore replace 0.75 with 0xCA. I think it is CA. C0. 1.0 with 0xFF. And 0.00 with 0x00. Something is wrong. Ah, yes. Okay, there we go. Okay, width is not in scope. Yes, this is template width. Ah, yes, this is no longer a template pixel. This is a template. Unused imports. We like those errors. Okay, I need import data byte string. Yep, that looks correct. Embed file not in scope. That's because I forgot to import the library that we added to the project earlier. So it's data file embed. No such file. Templates function. It's probably relative to. Oh, yeah. I'm assuming since I'm compiling from a different folder, um, yeah, it doesn't specify where it should be looked at. Because since I'm here in this file, definitely has a templates function. That means it must be relative to something else, and I don't know what it is. So I probably want to embed file relative to the project root. So it's gonna be an embed. Well, actually, I want to replace embed file space this. I'm gonna want to embed file relative, and it's gonna be from the project root is gonna be in stages assembly templates, I think. Yep. Yeah, this is starting to be ugly. I think I really want to make some kind of template Haskell thing that does this for me at some point. No such file or stages assembly templates function. Where's my typo? Because oh, it's lib. There we go. Okay. So instruction is missing in this file. It's missing as a result representation bytecode. We're in the home stretch, I think. Image is going to be the one imported from this one. Although I'm tempted to just... maybe I should merge those two modules rather than having template and templates per role. Maybe that's bad. Yeah, let's have templates here and template here. And let's copy all of that into templates here. Okay. What are we missing? That should be all of it. So that way we have read template, make image. All of those are actually, they can stay. Actually, yeah, I could just not export those things. They are now local helpers to this stuff. All of this is now just implementation details. I think I'm just going to export everything just for tests purposes. But now, Yeah, I'm just gonna leave them here. But those are now implementation details, because the only thing we care about are the templates themselves, which are here. Okay, so now I can delete template singular. And I can go back to assembly and only care about templates plural. Okay, initial image not defined. Initial image for now it's going to be undefined because I want to test just the generate image. Lenses are an annoyance again. So this is going to need to be below this. And just to be clear, this is a function image, actually. Which means assemble is going to need to be at the bottom of the file again. So it's going to be generate function image here. Okay. GHC stage restriction. Oh. It's not make lenses? Huh. What is it then? Control lens TH. Make lenses. No, that's where it is. Oh, it's make spelled out. There we go. When just M, that's here imported from control monad extra. Current row not in scope. Current row is going to be it is uses current image and we apply the function rows. Blank line template is not, I think it's called blank template. Oh, maybe it just doesn't exist. But I think there is definitely a blank. Yes, there's a blank. So it's just a matter of adding it here. The text branch has no argument. Okay. This is supposed to be a state, assembly state, unit, and it's complaining that it is not because some branches are... Oh yes, here I'm still taking a bunch of arguments that make no sense. Instruction. Yeah, no, I need to have the case here because I need to be able to do the instruction here. Okay. Prev image. Is that correct? Is this use of rows here correct? Because we are modifying the image that has already been extended, but no, the other line that which we want to write is the one based on the number of rows of the image before being expanded, so I think this is correct. Image and scope, this is prev image. I'm tempted to rewrite it using the other operator. So this is now prev image, on which we first apply a function which is canvas size, and then we then apply this the superimpose function. Okay. Prev color, this is the wrong operator for this. Couldn't match. Traverse append instruction. That should be fine, as long as optimize push does indeed give me because append instruction takes an instruction returns okay. So optimize push should be giving me a list of instruction resolved, and optimize push. Yeah, it looks like it's what it does. Oh, here I do an optimize push without giving it an argument. This is optimizing push for D. Okay. Yes, prev image. Here makes no sense. That was the whole point. Push n is supposed to be calls push n minus 4. Does this expand? So it should be fine. Oh, because use is it's a use, not uses. Okay. Yes, push doesn't exist. Those are all push int. I missed a few. Initial state green function template. Ah, yes, I'm assuming, of course, this is now something that needs to be applied to a column, and this is going to be, let's say, green there again. What are we complaining about now? Expected list of word 8. That's very interesting because that's very wrong. I'm assuming that's because I'm guessing it's because my add function is wrong type. No, it's fine. It's fine for any type. Okay, so it's not the problem. that's because here on I'm doing something on max height. I'm using a maximum of a map, and it's guessing that's a word 8. That's interesting. I don't think that's correct. Oh, is it because I'm using the wrong function? No, it gives me an int. Rows is correct. So images here is a list for which... Oh, because that is not giving me a list, of course. There we go. Which means I can probably rewrite this. This is a map of fmap generate function image of functions. There's probably like an fmap squared or something. Like an ffmap. I'm sure that exists. So I want a function that, given a function of a to b and an f of g of a, gives me an f of g of b. Huh. Oh wait, no, that not is package. It doesn't find anything. That's fascinating. Because if I search for this fb, oh, something is broken. I have a function from a to b, and I have an f of a, and I want an f of b. It should find f. Okay, it finds fmap. Now, if I have an f of g of a and I want an f of g of b, I must have had a typo before. There is a few protoludes, yeah, but none of them are in packages I want to depend on. Okay. And in my prelude, did I define anything like this? No, I don't. I haven't. Okay. I guess map fmap is not the end of the world. Okay. Import of data file embed is redundant. We love to see this. Ah, yes, this defaults integer because I have not declared what my add function thing is. Let's say int to a, so that it is no. Okay, so it is gonna be an image, takes some int and something, returns an image. There we go. Max height, max width, orange hues. I'm gonna command them out. And now we should have something that compiles. Okay, so now we should be able, let me see how we can write an image to a file. Huh. Display image actually makes a call to an external viewer. Fascinating. Let's see if that works from the GHCI. Okay, so now what do we want to do? We want to try generate function image which, given a list of instructions, gives me an image. Let's say that there is an entrance, and then there's push. Let's try 42. Which should be 16 times 2 plus 10. And terminate. This is a push int. Okay, so that is... Okay, we have an image. And now if I import graphics.image and I do... Is it display image, was it? Display image of that image. Index out of bound. Great. So I'm assuming a right image somewhere. No instance for writable. Output format. Wait. So this... So it only knows how to make images with double precision. So I would need to convert... Ah, this is annoying. There's no right image. Why? Wait, no. Oh, RGB word 8 can be written to PNG, but RGBA word 8 cannot be written to PNG. Come on. Oh, wait, no, it is. But VS, which is vector storage. Why not VU? Is it just a matter of switching to VS instead of VU in my... If it's just that, it's not going to be complicated, because it's just here I define an image as being that. If doing VS here is enough for this to work... No instance for writable image VS RGBIA word 8, but writable image VS RGBA word 8 PNG. Is it just because it's not sure what the output format is? Maybe that's just the issue. So maybe I just need to specify a right image and give it the... So what do I need to say here? In order they are... So a write image where I specify that the color space is RGBA, that E is word 8, and that output format is PNG. Ah, no, there's another type first, which is the array. Um, mm, mm, mm. So the first should be VU. Oh, wait, no, that was correct. That was RGBA first, word 8 second at PNG, and right, CS appears first, and that's RGBA. E appears second, that's word 8. Array appears next, and that's VU. No, okay. Oh, wait, output format is... What is output format? Oh, so this needs to have writable, not... It's not a type. Okay, so it needs to be writable for output format. Okay. But I don't know... That's why. Okay. Writable only exists for with a not specified output format, only for double. So I guess I would need to use another function than this one. So I need to find a way. Is there like a write PNG or something? This is a bit annoying. So what does write image do? Let's look at the source. Okay, so it's just an encode. So I guess I can just force the encode. Yeah, okay. So I can just remake this myself, basically. So I can change this to be unboxed again. For the sake of this, I'm gonna make a write function, which is gonna be this. I'm assuming that this BL thing is a byte string or something. Yes, byte string lazy. So write path is this, and it's going to be encode PNG. And therefore import data byte string lazy as B. Oh, as BL. Okay, so now I should be able to do write foo.png of an image, and I have no image in scope. No instance for writable of this and PNG. Oh, is it because it's only VS there again? I am not super familiar with this library. Sorry for the time wasted on this. Okay, so now I can write images and they are still crashing, so something is wrong in our indexing somewhere. So I guess one very easy thing I could do is in assembly here. So it's probably in the expand. That's at some point we do something wrong. And as a result, I guess I don't need both values because it's always gonna be the of like this is always those two, the sum is always gonna be the number of lines of the template, which means the offset is probably enough and avoids the risk of me having the wrong thing. Okay, so we do this. And now, so that's the template. The canvas size is the number of rows of the previous image plus new rows, and new rows is now just the number of rows of the template. And I probably still want to add an has call stack here. So that when it crashes, we have the call stack exactly, hopefully. Okay. I guess expand. Yes, I still have new rows as an argument, which is no longer required. There we go. Oh no, I'm not expanding by the number of rows. I'm expanding by the number of rows minus the offset. Here expand 1, 0. Expand 0. I wonder if it's just a matter of like some of my templates are not passed properly. Could be something like that. This MK template. I'm gonna call it F. It's not a great name. Okay, now with Haskell stack, we should be able to get no, we didn't get a call stack. Okay. All that for nothing. So instead of this, we are gonna import our good old friend debug.trace. Actually, before I do that, let's have a look. Let's have a look at if I take, for instance, entrance template and I give it green. That gives me an image that's wrong. So my templates are wrong. Yeah, index out of bounds 6060 seems very wrong. Okay. So I think my template width, template height is wrong. Oh, I need to be very careful. I think, yes, I have width and height here, but when I make an image, I'm saying width and height, and I think that's wrong because I think make image actually takes the number of rows and the number of columns. Where's that library again? There it is. Make image. Rows, columns. Yeah. Okay. So here I need to either change this. I'm going to change this to be rows and columns. So this is NB rows, NB columns. Which is basically length of rows. And this maximum here. Okay. And now this is rows and columns. And this is not... This is the number of columns plus C. Times R plus C, I think. I still have a width somewhere. Oh, that was the one. Okay, debug trace unused. Yeah. Because we figured out that the problem was in a template. Okay, that compiles. Okay, if I now try to do entrance template in green, it works. So if I display image... Oh, it's open it in GIMP. That looks correct to me. The colors are different because we did not start with red, we started with green. But this is definitely green to dark green, which is a push. And we do have the white line here that's inserted after whatever comes before. Yeah, that looks okay, I think. The structure at least is there. So now, God, making GIMP extremely cursed. If I try to make the image for a function, it is very wrong. Okay. A lot of things are wrong. What's interesting is that I can see that a lot of the stuff was added properly. Like the entrance has been added, and there's 3 lines below it which seem to match. No, that's not enough. Something is wrong. Okay, so let's try to display image of an entrance. Not entrance template. Let's try terminate template. Yeah, that looks correct. The templates look correct, which is interesting. And if I try function template, yes, I think that's what we want. Okay. So the templates are correct, and now this is the assembly that's wrong. So I'm guessing something in expand doesn't work. Oh, this is rows and columns, and I've used X and Y as usual. So this is this and 10. I'm gonna have it correct here for the superimpose, so I don't know. I had the same problem in my Advent of Code library, where for a while I had my point structure being Y, X, rows, columns, and then I switched it to X, Y, and everything became very confused very quickly. Okay, so let's try again. Generate the image for a function that has an entrance, push int 42 and terminate. Display that image, which again opens it in GIMP, which is fascinating. And we have a function. Something is wrong with the entrance. I was expecting. Oh, superimpose. That's annoying. Superimpose replaced what was there with transparency. Okay, so the superimpose function does not do. Hello. The superimpose function does not do what I thought it would do, which is actually like multiplying properly, like using the transparency thing. So we need to change our user superimpose, but otherwise we do have the entrance here that does go here, and then we have a bunch of stuff that is wrong, because that is very empty. I'm guessing this is the. Yes, but it is a bit off. Something is a bit wrong. I mean, the entrance template is correct, but something is missing here in the instructions. However, the terminate one is correct. Yeah, it's starting to look like something. The entrance is correct, I think. So the push is wrong. It's very big, but it's very empty, which is wrong. There we go. That's what is missing. And I don't know why here there's something that takes only 2 with it should not, it should be more than that. So something is wrong here. Oh, there's something else that's wrong. There should be a white line below the entrance. Let's go back to the entrance template. Here there should be a white line. And the reason for this is otherwise the transition from this thing to the next would encode in. Oh, actually, no. Actually, no. Give me 1 sec to think about this. No, I need something else. That's wrong. So basically, whatever the next instruction comes after this, it needs to know the previous color after this to know what the color it should put afterward is. The problem is, I don't think I have an easy way of saying, okay, you're gonna go here, entrance, and let's go back to assembly. Basically here, when I push an entrance, I would like to then overwrite after this use of expand. I would like to overwrite this to I would like to override this so that the next color is the color that the instruction needs to. No, I need to then set the color to that color here, so that whenever we go from this color to the next color, we can encode the instruction. Okay, so I need to remove this line. And here I need to. That's a bit hard-coded, that's a bit inelegant. I will need to force, not here, in here, I'm gonna force the current color to be something else. And I'm gonna force it to be whatever I is from the previous color. I from the previous color is +4 +2. So that means I am applying a function to the current color, and that function is it step color or something? It is next color. Let's flip next color. Oh, actually, I'm just gonna flip the next color. And wait, no. And it is step. Okay. And I think, yes, I'll switch this to be color here. Okay. Wait, why was terminate using green? No, it was using red. Okay, all good. Okay, so now we have step like this. So now I can just say step, and again we said that this little I was 4-2. Oops. Yes, I need to change the order of the arguments here as well. There we go. So here I have step that I have changed the order of the arguments. Okay, this compiles. So now if I try this again. Okay, so that's still wrong. That's still the push is very wrong. Okay, so we need to figure that out. But first, I'm gonna need to find a way. So superimpose doesn't work. Which is very annoying. Because I think multiply Yes, multiply need to have matching dimensions. Uh, so I'm probably gonna have to make my own. 'Cause multiply, yeah, multiply. Oh, that's gonna be annoying. Is there more stuff in processing that I have missed that will give me other ways to do? No, superimpose doesn't say anything. No. Okay. Well, that means I'm gonna have to rewrite my own function for this. That's fine. Let's look at the not translate. Let's look at the code for superimpose. Um, and let's copy it and let's update it to actually respect transparency properly. Apply template. It's gonna be this function here. It's formatted. We remove this. I can skip this since I can enforce that this is an image, my type of image. Okay. Apply template. So yeah, this is just basically going through. God, this is not very easy to read. Okay, I see. Do we do a get in the first image or in the second image? And this is where I disagree. So we, in the case where we get from image A, we need to. So what's the type of this? It's a function from int to int that gives me a pixel. And this pixel is going to be a pixel RGB A8. And what do I have from how do I get anything from a pixel? How do I decompose a pixel? I guess I can try this, just getting the pixel RGBA. So in this case here, I need to do pixel A equals this. So I guess I can just do it in all cases. I don't know, I cannot do it in all cases because maybe it doesn't exist. And here I'm gonna want to do, so I'm gonna assume that I can decompose those as being pixel RGBA R1 G1 B1 A1, and this is 2. And if that's the case, that's still gonna be the problem of not using double but using a word 8 here. So this is going to be I guess I don't care about the transparency of the background. Wait, no, I'm in the wrong. No, image A is the template. Okay, yeah, okay. So image A is the template. That's correct. So I only care about the transparency of the template. I don't care about transparency of the background. What I want to do is multiply. Yeah, so I have a word 8 here. So I'm gonna want to basically go through doubles. So the result is gonna be a pixel RGBA, for which R is gonna be a round, I suppose, of from integral. It's gonna be a nightmare. That's gonna be a nightmare. Unless I do, there's a convert function, and I can probably convert this to an RGBA double. That being said, no, I'm gonna cheat. I'm gonna cheat. This is too ugly. Since I know that my templates are either fully transparent or not transparent at all, and I don't have double values but word 8 values, I'm just gonna test to see if the transparency is 0. So if the transparency is 0, then we use the background image, and else we use the pixel A. Okay, so now I need to go back to assembly And I need to replace all uses of superimpose with apply template. And that was the only one. Perfect. So now I just need to put a bunch of I up in front of function names. Perfect. Now let's try again to see if at least this transparency problem is resolved. Generate function image, display image. Okay, that seems to work. At least for transparency, that works. We're now probably superimposing images. The push is still wrong, however, which is very interesting. So now, time to debug. I wonder if my templates are wrong as well. If I look at instruction template, it's okay, it's all four, that's fine. Push 1, okay. Push 2, okay. And push 3, okay. So I wonder if I'm just having a bunch of blank lines, if my blank line computation is wrong. Assembly. What did I do? Okay, so we encounter a push. Push, the one that actually does the stuff here, is I expand with 0, push 1 template, push 2 template, push 3 template, push 4 template. Otherwise, I get the current color. I do the push, I reset to the previous color, and I expand 0, push 4 template. Yeah, that looks fine to me. And I think if I go back to color, now push is indeed a 0, 1. So unless somehow the current color was set to white, nothing should be wrong here. I think I'm gonna do here, I'm gonna do a trace show ID to display the value of the optimization that we have performed. Okay, so push 42. It looks good to me. Push 42 was translated into push int 2, push int 16, multiply, push 10 int, add. That is pushing 42. I'm surprised at the 2 being after before the 16. Oh, yeah, that makes sense. That makes sense. The only downside of doing this optimization at this point is that the optimizer cannot see it. I guess the optimizer is no longer running at this stage. I think that's fine. Plus, the optimizer is mostly going to be on the IR, not on the bytecode. Yeah, I think that's fine. Okay, so this optimized push seems to be correct. So we are going to see afterwards a bunch of push that are less than 16. So we should be entering those. And that's a push to. So that should be an expand 0 push to template. Do I have an error in the names here? Push 2 is push 2, push 3 is push 3, push 4 is instruction template, and push 1 is push 1. No, that's correct. Okay. So I expand 0, push 2 template. Somehow, when I do this expand and I push the things, it pushes a white line. Because this is definitely a push 2 here. And then something else happens. Or is it the push 10? I wonder. What happens if I try to display the image of push 2 template green? Yeah, push 2 template green. Yeah, that looks pretty good. Actually, if I go back to those instructions, so not push in 42, but to those ones, and what if I make an image with this? I'm just gonna make an entrance first, and then those instructions. We have the same problem. Interesting. And if I don't have the entrance, what's happening? Huh. Okay, so the push to is correct, and then something happens with the color that makes it wrong. Could it be? Could it be that I have something broken in my next color here? Display image. I do encounter dark green, light green, light green, light green, light green, dark cyan, light cyan, light cyan, light cyan. That's wrong. That's just wrong. Wait, no, that's dark green is 2 and then it's push. Huh. Because that's actually, no, the color is correct, I think. Yeah, no, the colors are correct. The question is, why doesn't this light green appear? There's something about this where it gets superimposed on the wrong line or something. Could it be that my templates are wrong? Push for. That doesn't exist. Push 3. Oh, that looks correct to me. Something in this function is wrong. Because we're not trying to generate an image in the wrong color, so it's not that. It's not that is at the one index, so this should be fine. I guess I could try. Yeah, okay. All of my templates are indeed 1 row, 10 columns. That is fascinating. Okay, so let's try something else. Let's try them one by one. Push int 1, push int 2, push int 3, push int 4. Those are the basic ones. Aha! It's the 4 that's broken because 1, 2, 3 work. 4 is broken. Because there's no push 4, it is just the instruction template, which has the thing here. And push 4 template is instruction template. God damn it. Instruction template is blank. There we go. Blank is blank, but instruction template was also instruction. I should have made some template Haskell to generate all of this for me. That would not have happened. Okay, so now with this done, if I go back to generating a function that has this push int 42 and I display it, that is starting to look like something. So we have the entrance here that does the loop here. Starting from this color, it does. Oh, wait. No. Oh, shit. My instruction thing sees the instruction and applies the color to the end of the color transition. For push, it's the other way around. For push, it has to be the source group of pixels that determines the size. So all of this is wrong. A shame. Otherwise, push 2, push 16, multiply, push 10, add, like it's all pretty clearly there. Although I don't know where this add is in 2 lines. That doesn't make sense to me. That doesn't make sense to me. Oh. So I think it's a problem with my terminate template. Ah, yes, yes, yes. I know why. That's because when I am doing, if I want this to be, so this is, I probably want this to be offset 0 or offset 1, I guess, because the problem is I'm expanding the previous thing with edge, which will, yeah, so that's not correct. So I think if I want this to be, I just need to make it white here. Okay. So now we have only a gigantic problem left, which is that push instructions are not encoded correctly because the size of the block of something depends on the next instruction. That is fun. That is fun. So I guess what I have to do is always be conscious of the next image, of the next instruction, basically. And yeah, I think I need to always be conscious of the next instruction so that I can determine the size of a block of an instruction by whether the next is a push int or not. That's what I have to do. Which is slightly unpleasant, but not the end of the world. That means, however, I'm gonna have to rewrite a few things. Oh god, it's super late. I've been streaming for 5 hours? How did that happen? We are gonna need to change a few things. So first we're gonna have to replace all of the push ahead of time because all of the push will need to be translated into a series of smaller pushes and and like add multiplies and stuff. So we need to already do that ahead of time. So first here we're gonna add a few more things. This is gonna be indeed a traverse of app and instructions, but before that, we are gonna do a concat map of resolve pushes on the instructions. which I guess I could rewrite all of this as being 0.3 because I don't need the instructions for any of this. Okay. Resolve push is going to be a function that to an instruction resolved like associates a list of instruction resolved. And resolve push is a basic case of push int n, and we do something there, and any other instruction, we just return the instruction and we do nothing else on it. In the case of push int, this is the optimize push, and here I can do something where, like, if n is less or equal to 0, then error ice, internal compiler error, this should never happen. We should never generate bytecode that contains this. It would be better if we could represent it with a type that allows this, but again, that would be a wet63, which is not a thing that exists. And otherwise, we have some value n. And in this case, we can do the optimize push thing, and that's just going to be a go here, go n, and I'm going to make this a local function within this. Okay. So now, after we're done with this, we have resolved all the pushes. Now, when we're trying to do the assembly, we should never encounter... Like, we have already filtered this case. We should never encounter anything else, but we can keep it that way, I suppose. So I guess here is just a push n. Except, again, the size of the push is dependent not on the instruction, but on the push itself, but on the instruction that came before. So that means I cannot use append instruction anymore. I'm going to have to do... I am going to have to fold myself, basically. And that's going to be unpleasant. And I guess I am going to make that part of this function, I suppose. Okay. And now our go function is a case of the argument. If we are on the empty list, we have nothing to do. If we are on a list that contains... actually... So, resolved... Well, inlined is going to be concat map of resolve push of instructions. And we are going on... Wait, no, no, I don't. No, it's fine. I don't need to zip. I was gonna zip with the next, but I don't need to do that. This is fine. So here, if there's only one instruction left, then it does not depend on the size of the next one. So it's all good. So I can just append of size 4, I guess, is the default of X. However, if I am in a situation where I have some instruction I, some instruction J, and the rest of the list L, there's the first case where this is a push N, and I need to append with size N this instruction I, and then continue recursively on push N L. And I need to handle, or I guess I could handle it differently. I could just write it as IJL. There's at least 2 instructions left. And this is a basically case of J of push N append N I. Any other instruction after the current one, I can append the current one with size 4. And when I'm done with this, I go recursively on the rest of the list JL. Okay. And now append is this thing. Maybe I'm gonna just say append instruction. And I'm gonna keep it a separate function. But the difference is this is gonna need to be above. This is going to need to be above as well, just because of template Haskell forcing me to care about the order of the functions in the image because of the lenses. So append instruction will now take an additional argument, which is an int, which is the size of the instruction to be added. How does that work? How does that work for entrances? Ooh, ouch. Hmm. I think I need to change something. I think I need. I think I need to handle the case of like special blocks separately because I cannot just change the size of the previous instruction. So I think an int is not great. I'm going to use a maybe int and use nothing when I don't care about. Okay. I think that's better. And now I just need to figure out how to do this. Because I think for all of those, it's pretty straightforward. Um, because now push is no longer special. It's purely a matter of, um, yeah, it's purely the n here doesn't actually matter. It is purely a matter of expand, knowing how many instructions need to be put at this one before the next one. And I guess when I'm doing one of those, entrance, return, branch, and terminate, I guess terminate I don't care, because a push that happens after a terminate, yeah, actually entrance is the only one I care about. Push will never happen after a return, a branch. It could happen after a branch, however. No, I'm wrong. After a return or a terminate, there's no control flow from that instruction to a push, so it doesn't matter. It's irrelevant. It's not the case that we're ever going to generate. Branch and entrance are the only ones. Here's the thing I could do. I could cheat and insert a fake instruction that does nothing after my entrance and after my branch. So at the end of entrance here, if I add a white line, then I can make sure that I set a fake instruction, whatever it is, that does its size like well, just that will be the one with the size, and that one will be the one that will be followed by a push. And I guess I need to do that regardless, because any entrance need to have a starting color so that the next instruction can do something. So I need to do that anyway. So any entrance need to be followed by an instruction, a fake, like a line of color, regardless, so that the thing can do. And I just do that for, yeah, okay. So I'm going to do that for entrance, and I think I'm going to do the same thing for branch. I already have the empty line here. That's perfect. Okay, so that should not be too complicated then. So here, when I'm doing an entrance, I am doing an expand, and I'm giving nothing. I am not trying. Does that make sense for nothing to be given as the argument to expand, or will expand just be... No, I think that makes sense. I can probably write it that way. And then afterwards, when I'm done, I don't need to set the color this way. Whatever the color was at the end of this, which is probably the same color as before, that's all groovy. What I need to do is I need to do an append, a fake append instruction with the size, and it needs to be, it doesn't matter what it is, but let's just say a push. Push is, what instruction do I want that's neutral as a start? Let's say something that like rotates a tiny bit. So let's do a 1-1 One step, one darker. It's a subtract. Okay. Okay. Perfect. And the only one for which I need to do that as well is branch. No, I think it makes more sense to make the instruction template being like expand should just be here's an image, paste it. So I probably should make something that generates the instruction template given the size. I think that makes a lot more sense. So those are special. I'm going to put them separately, and branch is special as well because it does its own expand like this, and then it does an append instruction as well with the size and subtract. Okay. And so all of those, this is just an expand 0. Size is ignore for return terminate. They don't, it doesn't matter. And for all of the others, this is going to be sized instruction. So this needs to be a function that takes a color and creates a template. I think I'm going to make that in here. Sized instruction is given some maybe int will return and the color will return an image. Oh, actually, no, it needs to be in here because I'm gonna make use of expand itself. Actually, none of those expand directly. This is just going. Okay, so how do I call the function that takes care of, I guess, just sized instruction? Okay, and finally, what is sized instruction? That is a if we don't have a size parameter, that means we don't care about the size of the thing. This is a simple expand 0 using the instruction template. Otherwise, if it's just some size s, then what do we do? This is the thing we had push before that I'm gonna basically redo here. Well, this is just this push helper, basically. Yeah, I think it's just push S. Yeah, that should be fine. Type resolve push. There's a typo there. Push int. There's no longer any instruction called push, and I need to make sure that I don't have that mistake. Yes, okay, it's here. That's fine. Okay, and with this, I think when it compiles, because it's not compiling yet, but it should instructions. What's wrong now? Probably a few things in here. Ah, yes, expand here is still given nothing. That's useless. Okay, what else? Nothing else. Perfect. So now let's try regenerating this again. Let's open it in GIMP again. And now that feels wrong to me. Oh, wait, I didn't. There we go. That feels still wrong to me, but differently. Because we have definitely something here that was inserted. Wait, no, it's fine. This is the push too. Because if I remember correctly, how is it called again? Resolve push. If I resolve push a push int 42, it's a push 2, push 16, multiply push int 10 add. Oh. Currently I crashed GIMP. Incredible. After the entrance we have a white line. We start with something size 2. We move one color darker, so that's a push. Darker, this is dark, so one darker means we're back to light. So that's the push 2. This is a 4x4 block. This is the 16. Then we move one darker, therefore that's the push 16. That is just a normal instruction because it is just a multiply. So the transition from this to this is the multiply. This one is size 10, and transition from this one to this one is a push. And then transition to this one is an add. And then we have the terminate block. Okay, we have function generation. Whew. We're not super far from having all of the assembly done. I'm kind of tempted to just push forward a tiny bit longer. This is going to be a very long stream, but because now the last thing that we need to do is here this add function, which basically combines, like, how do we make the original image based on the size of the functions, and how do we no, there's a tiny bit more work to do, and I'm not gonna do it this evening. Here's why. If I open this example here, what is left to do is basically, now that we have our functions with their entrances and everything. Oh, interesting. Oh yeah, I have white line here, so again, that's why. Um, oh, I should try, before I go any further, can I try to make a display image of, I want to try a few more things. Subtract, duplicate. Actually, I don't care that much about them. I care more about branch, and return, and then subtract in the middle for good measure. Aha. Our branch is wrong, I think. This should not be. Those two colors are wrong. Yeah, something is wrong here. So yeah, let's fix this first. And I'm guessing that's because first branch here has... No, that's fine, actually. The problem here is that the... Wait, no. That's not fine. That means that during my assembly here, I say that the branch is offset 0, which is incorrect. Branch is offset 1. Okay, so that's better. We no longer have the duplicated thing. However, we still have a duplicated thing, so I think we have the same issue in return. Or exit, as it seems to be called. Yeah, we have the same thing. The exit template needs to be with... There we go, expand with 1 offset. Now, go back to the templates. Does terminate need... No, it doesn't. Perfect. Now, the last thing is branch. Branch is wrong. Oh, wait, no, it's fine. I'm wrong. Branch is fine. Because branch is the switch directly. Yeah, no, it's fine. It is fine. Because this is the switch, which if 0 will stay on the left going down and will go through this, or otherwise on a switch 1 will go to the right going down, so we'll bump here and we'll exit. Okay, so now with the offsets corrected, we should no longer have extra lines. There we go. Perfect. Okay, so that's it. I'm gonna stop here. The reason why it's complicated now is we need to insert, like we need to do the template for the things, which is gonna be basically this push 1 at the beginning because we need to go to address 1, which will do a loop around the thing, and we'll have here at the top left of the image a thing to redirect it to this series of things that make it go down, basically. The only thing is, those things here will need... Those things here will need to be sized depending on the size of depending on the size of the number of entrances of each function. And that means that either I make them like, if a function has like 24 entrances, that's a big 24 vertical thing here, or I do some smarter things with space optimization for those things here, and that's complicated. And two of those blocks need to be sized depending on the number of entrances of each function. So there's a tiny bit more work to do. If it had just been copy pasting a one line template, I would have finished today. The fact that there is a tiny bit more to do means I'm gonna stop here. And I'll try to figure out nice and elegant templates for this kind of pattern, just because I don't want to just make like a vertical line of 24 pixels if we end up in a situation where a function is just too big. Yeah, okay, that's about it, I think. That was a lot. But yeah. I need to commit a bunch of things because I've worked on a lot. So this week we did the entirety of the linking and most of the assembly, which means next week we can finish the assembly and then we can move on to actually doing the real compilation stuff. Now that we have the AST on one side, the bytecode and the assembly on the other, we have the input and the output. We just need to write the middle now. Okay, well, that was an adventure. Thank you for tuning in. I'll see you all next Tuesday.